There's nothing like going straight to the source to see if there's a real problem. First thing I check, turbidity. How cloudy is the water? The cloudier the water, the more there is to hide.
So our first measure of water quality here at the Blanchard River in Findlay is going to be turbidity. So I have my turbidity tube and a pitcher. And so the first thing I'm going to do is fill the pitcher with beautiful Blanchard water. And then I'm going to fill just until it's about 10 centimeters. It's marked here on the tube. So carefully pour. Doesn't matter if you miss. Oops, too much. Alright, there, we're pretty close to 10 centimeters. So then you're going to look with your eye up against the hole. You're going to look just down at the bottom and you might see a black and white cross. If you do, you're going to keep going 10 centimeters at a time until you can't see the cross anymore when you look into it. Filled it up to the 30 centimeter mark by now, and this time when I checked I couldn't see the cross anymore, so that's going to be our indicator here for the turbidity at the Blanchard River. When we get to 30 centimeters we can no longer see the cross.
One last clue I've got to check out, dissolved oxygen. Low amounts of dissolved oxygen in water could mean a watery grave for animals that live here.
Alright, so our second indication of the water quality here at the Blanchard River is going to be the dissolved oxygen. That's the amount of oxygen that's in the water so that the organisms can breathe. So I'm going to go through the whole procedure with you and then we'll know what our quality is for this test. So the first thing I'm going to do is get in my nifty little dissolved oxygen kit, and it tells me to rinse the glass bottle 3 times with the water sample. So glass bottle, I want to fill it all the way and then just pour it right out 3 times. 2, 3. Then I need to fill it until it's all the way overflowing. If I trap any bubbles in there, that's going to mess up my reading. So when I put the stopper in, it should overflow. Do you see all those little drips come off of there? Awesome. When I'm done with that, I'm going to remove the stopper. It'll be helpful if you have a teammate to hold this for you. And I'm going to find the bottle marked 1. It tells me to add 5 drops of bottle 1. Whenever you're using a reagent like this, it's important that you don't touch it to the lid. 2, 3, 4, 5. That would cause contamination and make someone else's test not accurate. It then tells me to find bottle 2 and add 5 drops of that one. 1, 2, 3, 4, 5. It tells me that if my bottle's not all the way full, to add some more water to it, but yours should be full. You can check in with me if you have a question at this point. When we add the stopper, we should make sure that it overflows a little bit again. And then, can you see all that murkiness? Perfect. It should look just like this. We're going to keep our fingers on the stopper here at the top and turn it upside down a few times so that it can all mix together. So it should all be that like murky orange. Kind of looks like there's little bits floating around in there. That's exactly what it should look like. If it doesn't turn this color, it means that there's no oxygen. So this is a good sign so far. Now we need to wait for about a minute until all of that settles down to the bottom. You can tell that the top half is really clear and all that mucky, gritty stuff is all settled to the bottom. That's exactly the way we want it to be. At this point, we're going to take off the stopper. We're going to add 10 drops from bottle 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We'll add that stopper back in. It should overflow again. Just make sure there are no bubbles in there. Just a little bit that time. And we're going to flip it upside down a bunch of times until all that gritty stuff dissolves. It should be completely see-through, but it's going to be this like orange color still, and that's okay. This is now our solution. So when this is, that's pretty clear, looks pretty good. We're going to try to save as much of this as we can in case we make a mistake in the next couple of steps, because otherwise we'll have to go all the way back to the beginning and start over. So our next step is to remove the plastic container, which is the plastic one, obviously the smaller one. And it tells us to rinse the container, which is just to make sure there's no contamination in there. So we'll pour a little bit in. It's about halfway full. Give it a good swirl. You can just throw it back in the river, it's fine. And then it wants us to fill to the 5 milliliter mark, which is the bottom one here. I know we don't have a level surface to make sure we have a perfect amount, but as long as you're pretty close, it'll be fine. And then we'll put the plastic cap back on the plastic container, and we can stopper this bottle again and then set it down gently. You don't want to get any bubbles in your solution, so try and keep it upright as best you can. Then we'll take bottle number 4, and we're gonna add just 1 drop through the hole in the cap. This is probably the hardest step because you don't want to get this to touch the cap, but you also don't want your droplet to fall anywhere except in the hole. So right over the top. Oh man. Drop it right down in there. It should turn really dark pretty much immediately. And then we're just gonna swirl it to mix it together again. You don't want to get any bubbles in there, just until it's all the same color is fine. Then we're going to find our titration solution, which is the biggest bottle. It's bottle number 5. Hang on for just a second, I need an extra hand. And we're going to take the syringe and insert it into this bottle. And you're gonna measure exactly how much goes in here, okay? If we have a syringe, then we'll measure how much is missing based on the marks on the side, the tick marks. If we use a pipette like this, then we'll just count the drops. So we're gonna add 1 drop at a time, and then we'll swirl the container every time until it turns colorless. This is like magic. Again, we don't wanna let this touch anything. So here's our first drop and a swirl. 2. 3, 4, 5, 6, I'd say that's colorless. How about you? Perfect. So we have 20 drops, which is exactly 1 milliliter actually. That's our conversion. And then the last step is to multiply that number that we used by 10 to get our amount of dissolved oxygen. So 1 milliliter times 10, that's 10 milligrams per liter of dissolved oxygen.
Of course, I've got to look at the pH too. The pH scale tells me how acidic the water might be. A pH of 7 is neutral, which means right in the middle. But once it starts creeping towards 0, more acid enters the scene. Too much acid could send this river to the big sleep. I'm no hay eater, but I know that farmers need water and nutrient-rich fertilizer to grow their crops. But fertilizer runoff can be bad news for water. You get a couple of dark and stormy nights where the rain washes the nutrients into a river, and boy, oh boy, a whole bunch of bad stuff starts to happen. Algae starts to grow, and the next thing you know, the dissolved oxygen levels in the water go down. Fish need dissolved oxygen to breathe, and without it, the outcome could be curtains. I'll hand this off to you, junior water detectives.